Okay, the task is to implement the function StrStr. The function takes two strings as arguments and locates the occurrence of string x in the string s. The function returns an integer denoting the first occurrence of the string. So let's say we have, let's see, by my for our first string, and then let's say we have MYE for our second string, and we want to find MYE in our first string. So to do this, we can start by setting up some pointers, maybe an S1 and an S2, and then we'll also keep track of the start of the string that we find. And so what we can do is check S1 and S2. If they're not equal, keep S2 where it is, move S1 up, and then keep checking, is S1 and S2 equal? No. Move S1 up. And are they equal? No. Move S1 up. Are they equal? Yes. So now we can set start to 0, 1, 2, 3. And we say, okay, let's move both of them now. So S1 is now here. S2 is here. Are they equal? Yes, we can go ahead and move both of them up another step. Are they equal? No, they're not. So what we need to do is to first move S2 back to 0. We need to move S1 to start plus 1 so that we don't miss these letters that we didn't compare to the beginning parts of the second word. And then we need to set start back to like -1 or something. So then we keep going. So is y equal to m? No, it's not. So we move S1 forward. Is m equal to m? Yes, it is. So we store the index of S1. So that's at 5. And then we increase both numbers. So S1 is here. S2 is y. Both y's are equal to each other. Increase. They're both equal to increase, but now we're done looking at both strings. So we would return 5 as being the index where our string starts. Okay, so to code this, let's go ahead and make some space. Okay, so to code this, we're going to want to start with our function call. So public, it will return an int, which is the location, and StrStr, it's going to take two strings, so string 1 and string 2. To start off with, let's do a quick check if string 1 dot length equals 0, or if string 2 dot length equals 0, then there's going to be no matches. So we can just return -1, or we could throw an exception. And then if the length of string 1 is less than string 2, then we also know that it would not work out because there's no way that string 2 could be found inside string 1. So if string 1 dot length is less than string 2 dot length, then we can return -1. Okay, and then otherwise we can get into our algorithm. So we know we need a start. We'll start that at -1. We know we need a pointer for string 1, and that'll start at the beginning. And we know we need a pointer for string 2. That will also start at the beginning of string 2. So while string 1, or no, let's do while S1 is less than string 1 dot length, and S2 is less than string 2 dot length, we will want to do this loop. So first thing we'll check to see is if string 1 is not equal to string 2. So if string 1 at S1 does not equal string 2 at S2, and we also want to think about, was string 2 at 0 or not, because two things are going to happen there and be different if so. Okay, so if this condition happens, then we can increase S1 as such. Otherwise, it means we had a match, which means if they're not equal and string 2 is greater than 0, then at one point we had a match that we need to reconcile. It's greater than 0. Then we can say, what we said, string 2 will have to be set back to 0. String 1 will have to be set to start plus 1. Make that a little clearer. And then start will go back to -1. And then the other condition is if they're equal. So if string 1 at S1 equals string 2 at S2, okay, then if S2 equals 0, then we know that it's the first time, so we know that they're equal, so we know our start needs to equal S1. Otherwise, we can just increase S1 and increase S2, and then we'll finish our while loop and our function. Oh, and we'll return after our while loop, we will return start. Okay, so let's go through this and see if it works. Okay, so we'll go ahead and write these out where it's easier to read. By, my, and MYE. We'll number these 0, 1, 2, 3, 4, 5, 6, 7, 0, 1, 2. Okay, and we want to keep track of start, S1, S2, and I think that is it. Okay, so we've got start starting at -1, S1 starts at 0, S2 starts at 0. Okay, so first we look and see, are either the lengths 0? They're not. Is string 1 less than string 2's length? It's not, so we go in. So while S1 is less than string 1 dot length, which is an 8, and while S2 is less than string 2's length, which is 3, then we can come in. So if string 1 at S1, if that does not equal string 2 and S2 equals 0, then S1 plus plus. So now S1 has become 1, and we move it like so. Then it says if string 1 does not equal string 2 at 2, which they don't. So then if they're equal, they're not. So we go around. S1 is 1, 1 is less than 8, and S2 is 0, 0 is less than 3. So we go in if string 1 does not equal string 2, which it does not. So we go in and say string 1 plus plus. So string 1 is now 2. And then we come down. S2 is not greater than 0, so we didn't meet that second condition. And then the third condition we do not meet. So we just had moved S2 up. And so we go around. 2 is less than 8. 0 is less than 3. So E and M. So if string 1 at S1, which is E, is not equal to string 2 at S2, which is M, then they don't, and S2 still equals 0, S plus plus, and we don't meet the next two conditions. So we go again, 3 is less than 8, and we had moved that to 3. And we look and we say if M and M is not equal, that's not the case because they are equal, so we won't meet the second condition either. We'll go to the third. They are equal if S2 equals 0, which it does. Start becomes S1, so start is now 3. S1 plus plus, so that's 4. And S2 plus plus. Okay, so that becomes 1. And we go through, and 4 is less than 8, and 1 is less than 3, so we keep going. And if string 1 does not equal string 2, well, they do equal, so that doesn't work. The second condition will also fail. So they are equal. S2 is not equal to 0, so we just do S1 plus plus and S2 plus plus. Okay. Go around. 5 is less than 8. 2 is less than 3. We come in. If string 1 at S1, which is M, does not equal string 2 at S2, they don't equal, but S2 is not equal to 0. So we go to the second condition where S2 is greater than 0 and they don't equal each other. So then S2 becomes 0. So we move that. Start, or S1 becomes start plus 1. So that's 4. And then S start equals -1. Okay. Then we come in, and obviously they're not equal to each other, so we keep going. And we say 4 is less than 8, 0 is less than 3. We keep going. So Y is not equal to M, and S is equal to 0, so we just do S1 plus plus. Okay, so now we are at 5. And the second condition doesn't meet because S2 is not greater than 0. Second and third condition doesn't meet because they are not equal. We go around. 5 is less than 8. 0 is less than 3. We go in. If they're not equal, but they are equal, so we fail the first condition. We fail the second condition. The third condition is true. We go in. If S2 equals 0, which it does, start equals S1. So start is now 5. S1 plus plus, so that's 6. S2 plus plus, that's 1. Okay, and then we go into our while loop and we see 6 is less than 8, 1 is less than 3. We come in. If they're not equal to each other, that statement is false. Second statement is false. Third statement is true. Y is equal to Y. If S2 equals 0, that's false. So S1 plus plus, S2 plus plus. Okay, so we go in. 7 is less than 8. 2 is less than 3. Let's make sure we have our arrows on the right numbers. Okay, and then we go in. Is E equal to E? It is, so the first two conditions are failing. The second condition is true. And then if S2 equals 0, that is false. So S1 plus plus, S2 plus plus. So S1 becomes 8. S2 becomes 3. We go into our while loop. 8 is not less than 8, and 3 is not less than 3. It all fails. And then we return our start, which is 5, which we know is the correct answer. All right. And we know that this running time is O of n. because it goes through the array about one time. It does backtrack a little bit. So worst case, I guess it could be a little bit worse than that, but for the most part, it's just going to walk through the array the one time. And obviously, once it finds a match and it's completely gone through everything, then it would stop. So, all right, and then it uses no extra space, so it's O of 1 space.